Hi, my name is Chinedu Ojukwu, and this is mobile and pervasive computing. So what I was able to work on this semester was the automotive assembly assistant with AR feedback. So basically, to give a quick overview of the prior work that was done with this automotive assembly assistant, so we have a process in which cognitive assistant is being used to help the user assemble a car. So basically what this means in layman's terms is as you're building a car and assembling these parts, you're getting real-time feedback in terms of audio commands and visual feedback in terms of images and videos. But my project is kind of expanding that to add 3D animations and AR to kind of augment that process for users and to make it easier and more visually appeasing for them. State is going to be then sent to the supplementary Android device. So the other Android device is running AR Core. So basically the AR Core allows you to render objects in real time on an anchored workbench mat. So basically, as the second Android camera is recognizing the workbench, it'll then use the state that is currently being provided by the other Android device to give the state, and the state is going to inform which rendering to draw in real time. So basically, if you have a tire and you're in a step in which you want to render a tire, you're going to go ahead and create that 3D animation in real time as the user is also getting audio and visual feedback. And I chose to use AR Core for this project mainly because of the ease of development and the support that was basically given by the Google's API. And the API was really fleshed out and it was easy to code it in Java. And with this Java API, it allows you to import objects easily and kind of render them on each given frame, which allows for easy rendering based on state. So we're going to go ahead and get started with a quick demo of the application. So first we're going to start the socket on the first client device. So this client device is going to act as the server and is going to be able to share the state directly with the application running the augmented reality. So first, once the workbench is recognized, we're going to go ahead and start with a final product of what the car will look like. So we're going to go ahead and start from the beginning. So in this first step here, we're going to ask the user to place the wheels and the tires in this format, such as this seen on the right. So this being the first step, once the user is complete with that, the Kalo server will be able to recognize when the user has actually put these things together, and then it's going to go ahead and go to the next step, and it'll show a step complete animation, as you can see through the lens of the augmented reality. And once we load it ready for the next step, we're going to go ahead and show the user the next task he needs to complete. So if you see here, you can see the tires are inside the wheels, showing the user the next desired step for the application, such as this tire right here. So once we go ahead and complete that step, we're going to move on to the next step, which is to acquire an axle, such as the axle shown here with the car. And then once we've acquired the axle, again, we're going to be able to go on to the next step, again with the step complete animation. And the next step here would be to put the wheels that you already created beforehand into the axle you just acquired, as seen here. And as you can see, even if we move the workbench, the image is going to move with it, and it's going to track and follow the object as you move it. So if you complete that next step, the next step would be to acquire the chassis as shown on the right here. So once we acquire that chassis, we're going to have the next step of acquiring a gear, similar to the gear shown here. And then the next step reported by the server would be to put the gear onto the chassis as shown here, with the gear in the front left being attached to the front right axle. And then again, we're going to move on. And the next final step would be to have this axle that you created beforehand that's attached to the wheel and show how you want to be placing that onto the axle, as you can see here. So basically, as the first device here is acting as a server, and it's opening its WebSocket and writing output to the other device, and the other device that's running the augmented reality will be reading the input and informing of the next state. So as we can see here, you have the layout real rim as the current state, and that's going to match exactly the output that's being shown on the AR camera here. So this device here would be speaking directly to the Gabriel server. So as those neural network object detections are being run, it's going to be changing the state of the entire application, and the state will be forwarded to the first Gabriel client. And this Gabriel client on this Android phone here will forward the state to the second device. And as you move along with the with the steps and in the assembly process, as shown here, it's going to report the state, and which will directly change the state in the augmented reality application.